What's going on, everybody? Boris here at the Ecology Design Studio. Today we have a lot of ground to cover in this video. We'll take a look at Maven, but we will not use it. We're going to study how it works and why it functions in the way that it does. We're going to cover configuration, and we're going to use Maven in different videos down the road. This video is going to be split into two parts. The first, we're going to cover the basic, and in the second, we're going to take a detailed look in the Apache documentation to see more about Maven and its POM file. Let's jump right in. So what is Maven? It's a Java build tool. Basically, when we write Java code, we need to compile it and then package it. When we're creating web applications, there's a lot of things that go into that. JavaScript files, classes, we have images, CSS, cascading style sheets, JSP or pure HTML, many elements that come together to create what we think of as a web application. And what Maven does is we'll compile all our classes, package everything, and then create a WAR file, a web archive. It's basically an Apache tool that uses declarative build engineering, manages our dependencies, and helps us generate project documentation. We're going to learn about these three different things later on as we go through the slides. So why are we using Maven? We're using it theoretically because it makes our life easier than using something like Apache Ant, which we'll take a look at another time. So we reduce the complexity of our script, and we externalize dependency management, the external libraries that we have to pull in to make our project. We have a consistent set of build commands, and we integrate with external system development lifecycle systems in a more clean manner. Also, Maven is pretty well established. There's a lot of documentation available, and there is a common set of plugins that offer build functionalities that are the same across different projects. We'll take a look at Maven archetypes at another time and see how that offers the same look and feel for projects, the same directory structures and layouts, and how that helps us build consistent projects. We mentioned alternatives to Maven, so what are they? We have Ant and Gradle here on the screen. I've used Ant, never used Gradle, hoping to later on. Gradle, we can think of that as the combination or a synthesis between Ant and Maven. It simplifies our build syntax by eliminating XML scripting and replacing it with Groovy-based scripting. It supports Maven's dependency management and can interact with Maven repositories. It's used by Spring and Android. We're going to take a look at Spring later when we're creating RESTful services for our web application. I should also mention that Maven uses a declarative style of building, whereas Ant uses an imperative style. We're going to see that in the next slide. Maven emphasizes convention, whereas Ant emphasizes configuration. So what does it mean to have a declarative or an imperative style? I grabbed this from this link, which is available down in the description. A pretty decent description, I should say. An Ant script basically tells the tool exactly what we want to do in strict terms. We want to compile these specific files, then copy them into a specific folder, take the contents of that folder and package them as an archive, for example, a WAR file, a web archive. Maven, on the other hand, uses the POM file to declare what we want to accomplish as a result. It basically gives us the names of the libraries that our project depends on, and we would like to generate a web archive. Maven knows how to fetch the libraries, how to compile them, and how to create the web archive on its own. We should take a brief moment to speak on why we would use Ant over Maven in some situations. Maybe the project is unique or overly complex, or perhaps we're going after a legacy application. In that case, we're just going to stick with the existing build script. This is the POM reference, the Apache Maven documentation. We're going to take a look at this in detail in the second half of this video. Next, let's take a look at artifacts. An artifact is a file stored in the Maven repository or a file generated during a Maven build that is intended to be stored in a Maven repository. Every artifact, once it's stored, has something called a coordinate. Now there's things called release artifacts, snapshot artifacts, and plugins. To cover them briefly, an artifact is a release artifact if it's not a snapshot artifact. Release artifacts are immutable once deployed to a remote repository, and they should not, in theory, they should not be overwritten. A snapshot artifact, the version ends in -snapshot, and they're handled and stored differently than releases. A plugin is basically a jar file whose code implements the Maven plugin API, and they can offer us one or more goals. We're going to take a look at goals in a second. For example, clean, package. Those two goals will tell Maven to clean your target directory and then package it, which includes a compile process. Repository. What's a Maven repository? There's two types. There's local and remote. Local is something that sits on your local machine on the same operating system. Remote is something you have to do an HTTP get to get it from a server. Basically, it's a file system accessible by Maven that conforms to a Maven repository layout. An installation repository, the act of copying an artifact into a local repository, is performed by the install goal. Deployment, it's the act of copying an artifact into a remote repository, performed by the deploy goal. Now, when we say install and deploy, those are we're using those terms differently than deploying or installing an application, right? Deploying a web application on a web servers like WebLogic or Tomcat, and installing an application, installing a client application through some sort of an exe file. So here we're using Maven goals to put artifacts into either a local repository or a remote one on a server somewhere. Let's talk about metadata. That's data about data, information about your project basically, and Maven can store a lot of information about a project, and the developers, the organization, the groups, libraries, and more. Coordinate is a type of metadata. Remember how we talked about each artifact is assigned a coordinate? It's a formal description of an artifact's location in a repository. And there's 5 elements: group ID, artifact ID, version, packaging, the type, the default I think is a jar, and a classifier. GAV, that's an acronym that stands for group artifact IDs and version. So we need to specify a GAV each time we have a dependency. And we're going to take a look at an example of a dependency in a minute. The group ID represents the organization, the person, the team, whoever created and owns the artifact. Usually looks like a piece of a package, right? So when we write Java packages, we're going to call them com.google.mail, whatever it is, because, or com.mail.google, because it's an inverse of a domain name, and domain names are used as package names because they're unique, right? You can't have www.google.com go to 2 different companies. It goes to one, Google. And when Google releases an API, it ensures the packages they release are unique every time. So artifact ID, that's a unique identifier. It uniquely identifies an artifact within the namespace of the group ID. And it's derived from the application's formal name. Sometimes the GAV is used as a synonym for coordinate. Packaging or type, it's an optional string character that describes the type of the artifact. Like I said, the default value is jar, and the 2 most common artifact types is the jar, of course, and then the POM file. There's other types. We have EJB, Enterprise Java Bean, EAR, WAR, RAR, Maven plugins. There's many types. In artifacts, packaging determines its default build lifecycle, and plugins can introduce additional packaging types. So if we want to add more, we can do that through plugins. Classifier is an optional representation or optional description of an artifact. There's no default value, and I believe the 2 most common ones that are described in the documentation is Java doc and sources. Let's talk about executing a Maven task with goals or mojo. I'm not sure what the mojo thing is about. I saw it on the documentation. A goal is a specific operation that needs to be performed during a build. So for example, compile source code into bytecode, perform unit tests, create an archive, and we can think of those as ant tasks. Goals come from different Maven plugins, and we combine one or more goals to create a phase. A life cycle, on the other hand, is an ordered list of phases. Life cycles are predefined by Maven, and plugins can define additional life cycle if we want to. So I mentioned clean, package. The clean lifecycle cleans the project, the target directory. Default, it compiles, tests, assembles, deploys the project. and then site generates your project documentation. As you can see, these are three distinct life cycles of a project build cycle. Let's talk about projects and dependencies for a second. What's a project? Here we're interested in the technical definition of a Maven project. In general, a project is the resources and the things that we do to create an output. You know, basically we have multiple units of work with multiple people on a project, and then we have an end result, something that we can measure. Here a project is a POM file, optionally with source code and other resources that we use to produce an artifact, a Maven artifact. A POM is an acronym that stands for Project Object Model. It's an XML representation of a Maven project, usually in a file named pom.xml. XML is extended markup language. There is things called a super POM, from which all other POMs inherit their default values. We can think of that as java.lang.object in the Java object hierarchy. We can't modify it, it's built into Maven, and we can use parent POMs to impact many children at once. There's different things we can talk about and think about when we're looking at Maven projects. For example, inheritance is the parent-child relationship between different POMs, where children inherit properties and settings from the parent. Aggregation is where we're building relationship between POMs. They're not, the inheritance and aggregation are different things, although we can have a parent that aggregates its children and then they in turn inherit from the aggregating parent. Dependency, this is what we'll focus on the most. You know, our project dependencies, for example, if we're trying to create a RESTful service, we need to have Spring as a dependency so that Maven can go out and pull the jar files, compile them, and so on. A dependency is an artifact that is relied upon by those artifacts which we create during a project. We use this term to refer to the dependencies that are explicitly declared in the POM. Transitive dependencies, and I think I might have touched upon that briefly in the beginning, is a dependency of an explicitly declared dependency, right? So if we're inheriting from another project and that project also has dependencies, those dependencies, right? So we have project A and project B. Project A inherits from project B. Project B's dependencies are transitive dependencies to project A. Projects also have a profile, a POM subset whose settings are dynamically applied over the default POM settings. Profiles can be activated, deactivated. We're not really going to take a look at that too much. Let's change direction for a second and talk about life cycles, goals, phases. We saw the clean, default, and site life cycles, and we also mentioned that we can run a Maven command called clean and then package to clean our target directory and then package everything. So clean is a goal that is a part of the clean life cycle, right? That's the one we're usually most interested in when we talk about cleaning. And then when we execute package, that's part of the, I believe, the default life cycle, right? The one that compiles, tests, and creates our project. By default, the clean goal from the Maven clean plugin is bound to the clean lifecycle phase. The default lifecycle has a couple of phases, and they are compile, test, package, install, and deploy. Compile compiles our application code. Test compiles the application test code and our unit tests. The test phase executes our test. Package assembles the release packages. Install copies release packages into our local repo, and deploy. Remember install and deploy that we talked about before. So install, we copy it into our local repository, deploy into a remote repository on the server somewhere else. Switching over to goals, we see that they're documented in one of two ways. Either a long format where we do group ID, artifact ID, the version, and then the goal name, and then the short format where we do the plugin prefix and then the goal name. Version may be omitted in the long format, in which case the latest version in our local repository is used. The short format, the plugin prefix is always documented in the plugin site documentation, and if the artifact ID of the plugin fits either of the formats, the plugin prefix will almost always be derived from it. So we can do Maven -prefix -plugin or prefix -Maven -plugin. Now we're not going to set up Maven and then look at how to execute Maven goals and phases on our CMD. What we are going to talk about is the format behind it and the different options that we can use with it. So the format is MVN or MVN debug, which turns on Java debugging functionality. We're almost always going to use MVN. Then we specify our options, then our goals, and then our phase. And then we can append one of these things that we see here at the end of our command line. We can specify option B, D, E, and we'll take a look at each of these in detail. So B is batch mode. Maven will never prompt for input during execution and will instead assume defaults for those inputs. D or dash D is the defined property. It defines a JVM system property. It's a common mechanism for influencing a plugin's behavior at runtime. Dash O, offline mode. Maven will never initiate any connections to remote repositories. Every artifact required for a build must already be present in the local repository. Dash P, activate profile. We're not really going to worry about that. Basically activates profiles in a POM as well as in settings.xml. Dash U, we may need to use this sometimes. A force update. It forces Maven to look into remote repositories for updates to snapshots or releases. Only if version ranges are used, but that's a bad practice. We're never going to use version ranges. The Maven settings file. There's actually a few locations where Maven has settings, and it reads additional configuration information from this file. It contains remote repo definitions, authentication credentials, other settings. We're not really going to use a settings file for any of the projects that we do at the moment. It's usually if you're trying to connect to a artifact manager. Basically, the first one, M2 home, which when we configure our system variable, we'll take a look at M2 home. Under the configurations folder, that's where the settings.xml file is located. And then the second one is our user settings, and that's under whatever our user home is, then a folder called .m2, and then there's our settings.xml file. And if you have two settings files, Maven will usually combine them and then use the information in both. A default directory layout is usually imposed on our projects by Maven, and that's so that we can have a standardized look and feel. If we're going from project to project, we need to know where to expect our images, our JavaScript, cascading style sheet, Java server pages, and so on. Here I have the different elements that make up our project. We have our pom.xml file where we specify our dependencies, licenses, notices, readme text files, and then these different words with slashes, you can think of that as a folder, then another within a folder within a folder, right? A nested structure of folders. So we have our source at the beginning of all of them, and then either main or test. So main Java is where the Java code is going to begin, and that's also where a package structure begins. We're going to declare, right, com dot arcology designs dot statistics dot something else. Then source main web app resources. That's where I keep my cascading style sheets, images, JavaScript. Source main web app pages. We can do something like /pages, and that's where we can keep our JSP pages. I don't like keeping pages under the web end or directly under the web app. Well, source test Java and test resources. That's where our test code and packaging structure begins. Then the test resource files. So if we wanted to test our JavaScript and we wanted to use a behavior-driven development framework like Jasmine and something like the Karma test runner, we would include that under the test resources. And then in test Java, I guess JavaScript is a bad example. Let's use JUnit. So we include the JUnit resources and then the actual unit test and test/Java. There's documentation available on all of this, so feel free to take a look down below at the links and explore. We're moving on to target directories. It's an output directory. Anything that Maven creates is thrown in there. It's the main release artifact is in this directory. Target classes, that's the Java application bytecode. Target test classes, that's the Java unit test bytecode. Target generated sources is your auto-generated Java source code. And then we can have subfolders in there as well. Let's cover the pom.xml file in more detail. The POM for Maven project contains all of the metadata that we need, including project coordinates, dependencies, our developers, profiles and their configuration, and so on. We have different POM elements. We see down here an excerpt of the header. The header is always the same, and right now it's version 4 has to be specified. We can see here a link to the W3 organizations and how XML is interpreted. I don't have all that memorized. I'm not even sure what a lot of it is. But in the header, we have our opening project tag, then the model version must always be present and must always be set to 4. The project tag is the root element of our POM file. The GAV, the group artifact and version, has to be specified for every project. Packaging, we talked about that, default value jar. We have to specify all of the options. So if we're importing Spring, what's the group ID, artifact, and version that we're looking to import. There's optional data that we can store, licenses, links to Subversion or GitHub repositories for code management and versioning, version histories. There's also something called a module. A POM project can aggregate multiple module projects. Modules, they don't have to be listed in any necessary compilation order. Maven can figure out which ones depend on another and then sort them properly. A brief look at POM Supported Properties, and we can think of these as the ANT properties, and it has actually the same syntax. I mean, they're both Apache tools, $ bracket, and then the name of the property. So we can have $ bracket, curly brace, env.x returns the environment variable x, project.x walks the POM file and returns the specified value. So for example, we can do $ bracket or squiggly project.version, and it will return the project version. All the Java virtual machine properties, Java home can be accessible, right? So where's our Java home? We can specify that. User-defined properties are supported in the properties tag element, and we can see the syntax for that down below. So from the online documentation, we see this as an example. We have the basic declaration of a dependency. We're moving on to dependencies now. We have our group ID, the GAV, artifact, version, packaging, and then we start with dependencies, the parent, dependency management, modules, and then properties that we covered. Then we have our build settings, reporting. We didn't really cover that too much. We'll take a look at the documentation. Project information, right? Name of the project, description, URL, when was it made, license, organization, developers. As you can see, Maven can store a lot of information for that. Environment settings, our issue management, mailing list, the SCM, that's our SVN or Subversion, prerequisites, repositories, repos, plugin repos, distribution management, and then finally profiles. And remember how we talked about how profiles can be activated using certain commands, and then it can be activated in the settings.xml file in the Maven configuration directory for our global settings file, and then again under .m2 for our user specific settings, and how Maven combines both of those files. And let's talk more about dependency. Almost every project has some sort of a dependency. Maven will bring in the ones you specify and also their transitive dependencies, right? The ones they depend on. We can take a look at the dependency format as we saw previously. So it's going to be dependencies, plural tag, then dependency, then our GAV. Then we can include the optional type scope, type jar scope. It can be a test, and then optional, we don't have to include that. We can set it as false. And optional we can think of as excluded by default. So what are some of the other dependency scopes? Compile is needed in all class paths. Provided is needed in compile and the test class paths. Not provisioned by Maven to the runtime class path. It's not transitive. Compile is transitive as scope compile. Then we have runtime. It's needed in test and runtime, right? Test, the one down below. Test needed in the test class path. Not needed in compile or runtime, and it's not transitive. System behaves like provided, like the second one that we saw, except it's found in a file system and it's not searched for in any repository. It's also not transitive. We mentioned dependencies or inheritance, and we saw the dependency management tag a few slides up, but we didn't really go into depth on it. So we can have parent managed dependencies. A parent can use the dependency management tag to define default settings for commonly used dependencies. And these settings will be inherited by children. Children then only have to specify the group ID and artifact ID, and the rest of the settings are inherited. So we can also override inheritance settings if we need to, but we can get rid of the version tag, right? So we see down here an example, we have dependencies, plural dependency, our gav, group ID, artifact ID, but we see that the V is missing because we inherit the version from the parent. All right, that was a bit long, so I think we're gonna end it there. And if you'd like to join me, I'm gonna make another video where we go through the Apache documentation for the POM file, for the settings, and for all of that, best practices. And we'll take a look at that in more detail if you'd like. For now, the basics should cover it, and then we can move on from there into configuring Maven on our system. Right, we can follow the instructions on the Maven site, and then it'll get us to a place where we can run Maven from the command line. But we also want to configure Maven to work seamlessly in our integrated development environments, our IDEs. And in the previous video, we talked about IntelliJ by JetBrains and Eclipse, Oracle Eclipse. So we're going to set up Maven in both of those so we can use it from within the IDE itself, and that's going to be pretty helpful later on. We'll also see how we can deploy automatically on a WebLogic server instead of having to manually update our project every time. But we're also going to do a few manual updates so we can see the process for the manual process for deploying an application on WebLogic. Anyways, folks, this brings us to the end of this video. Thank you, and I'll see you next time on our Ecology Designs production.